Today, we will build a mutual TLS Go client that uses the macOS keychain to store its client certificate and client private key. So this is an ongoing series on the mutual TLS, and the link to the playlist for the previous videos will be in the notes below. So why would you use a macOS keychain? So previously, we built a simple Go client that used mutual TLS. It used standard library methods, but it had to load the client certificate and the private key from the file system. However, keeping the private key on the file system is insecure. If anyone else is able to get access to your file system, they can grab your private key and then pretend to be yourself. It is more secure to keep the private key on the operating system's key store, such as the macOS keychain on the macOS. So let's jump straight into the code, and this builds upon the previous work that we've done on the previous video, where we used a custom signer to sign the certificate. Looking for my mouse. Okay, there we go. All right, so we will use cgo to interact with the Apple APIs. Because the Apple APIs have a C interface. It's a little annoying because their documentation uses Objective-C and Swift. So it is a little tricky to figure out what exactly needs to be passed and returned from these interfaces. But it's not too bad. Okay, so we implement get client certificate method. So exactly the signature as it's needed for the certificate. And when we create a certificate, it takes in the certificate request info here, which we can use to do some additional filtering if we want on certificate. In our example, we only support this RSA PSS SHA-256 algorithm just for simplicity. It's pretty straightforward to add support for additional algorithms, but we wanted to kind of reduce the amount of code we have here. So here we do a simple check that we only support this one algorithm. Now this is the critical code, and we have a link to the documentation here. So the key method is this sec item copy matching, which grabs all the matching items from the macOS keychain. So the way you do that is you create this dictionary where you enter the things that you want to match on. This dictionary also contains the maximum number of matches you want to get. I kind of hard-coded it to 10, but it's possible that if you want to do some custom matching and you want all certificates, maybe this needs to be larger. So we do use a hard-coded common name, so we match by common name. And this is just an example. I think in the real world, we'd want to get this from environment variable or passed in, or somehow passed in. Okay, so what do we match on? We match on the identity. So an identity in a macOS keychain is the certificate and the private key. So that means we're matching on all items that have both a certificate and the associated private key. We have also an attribute that says can sign, because we will need to use the private key to sign the digest for our certificate verify message in the TLS handshake. Here's where we match on the common name. And I think this is optional, because one thing you could do is you can grab all the certificates and then later do the filtering in the Go code itself. Besides matching on the common name, the Apple API provides the ability to match on the issuer. So issuer is the certificate authority that issued this client certificate. And it gets an array of DER encoded ASN.1 items. So it's possible to get these from the info, because this info has a list of CAs that the server has. So I think info.acceptable CAs right here. So it has the CAs. So we can use these CAs and pass them to the issuers. Code is a little more complicated, so I felt like for this example, we will just match on a common name. All right, so we return an reference, we match, we return, all the matches. Okay, so once we run this, we get an array of identity matches. And here we go through this array, we loop through this array, and we convert this identity into a Go 509 certificate. So let's jump into this method to see how we do this. First, we convert the identity to a certificate. So we can convert the Apple identity into an Apple certificate using this identity copy certificate method. And then we actually export the certificate to our PEM format. So we use this method, sec_item export. We pass the certificate reference here, and we get back basically the raw data, which we then convert into a byte slice. And once we have a byte slice, we can use this method, which is pretty standard, to parse the data and get our 509 certificate out of it. Okay, so let's go back to where we got this certificate. We do a validation check to make sure it's not expired, because it is possible on the keychain to have basically certificates with the same common name but different expiration dates. So once a certificate is about to expire, the IT team or whoever is issuing these certificates can issue a new certificate with the same common name but a newer expiration date. So we just want to make sure we grab one that is not expired here. And next thing we do is we grab the private key reference. So this is just a reference to the private key. It doesn't actually contain the clear text of the private key. And one of the recommended security practices is when you're putting a private key into the macOS keychain to make it non-exportable, which means that no one is able to get out that private key from the keychain with clear text. The only thing you can do is call the API method to sign something using that private key, which we'll go over later, but no one can actually get the private key out in clear text. So we get the reference, which we will later use to sign the digest for the certificate verify message. And here we have our custom signer, which is kind of the same approach we had in the previous video where we made a custom signer. Set finalizer is just cleanup, because this is C code, so we need to deallocate the memory. So we need to deallocate the memory for the private key. And here's where we get where we create the certificate. The certificate that we generated, the custom signer that we created up here, and here we just specified the one algorithm that we do support. Okay, so once we get this, in the TLS handshake the certificate is retrieved, I think the next most important thing is to sign, use the private key to sign the digest. So let's go over to that code like that. So this sign method is the next critical piece of code that we want to go over here. Okay, so we get the digest, which is a byte slice, and we convert it into a CF data ref, which is used by the Apple API. And then this is the key method here. It's a key create signature, where we pass it the reference. This is a reference to the private key, the algorithm we want to use, and the digest data. And here's a link to other algorithms that can be used, and we can figure out the algorithm based on the signer opts, right? Based on the signer opts, we can figure out which algorithm needs to be used. But in this case, we will only support a single algorithm, this one, for demonstration purposes. So basically, that's the key code. Is you just call this method, you get back this data, which you then have to convert to byte slice over here, and then return. And putting it all together, this is our main program here. It's going to take a URL, and then here's where we create the client. And basically, this is this key line. So this is the key line over here, where we just tell it to get the client certificate. We call this method, right? This is just reducing the scope to TLS 1.3. And then we use this client to get the URL path, and then we print out the body. Okay, so I think we're ready to actually use this. Okay, so let's go to the terminal. So we want to do go build, and it was client signer. Okay, now we have the client signer executable. Now we want to generate private keys and import them into the generate the certificates and the private keys and import them into the macOS keychain. So we'll do that here. So we basically use the same approach that we did previously. We call gencerts, which will generate a bunch of certificates in our certs directory. It generates all these certificates. And then we call import, and let's just look at the import. So the key part of the import that we added was this client signer, right? And this is the app that we just created. So the reason we would want to do that is to allow this app to have access to the private key. It won't be able to export it because we passed in a -x, which means this private key is non-exportable. But it will let that app use that private key to sign things. If we didn't pass this, it would still work, but every time we ran this, we would get a pop-up saying, this app is trying to access a key, and then we'd have to enter our username and password every time. Okay, so let's run this. We're using sudo because we're going to import it into the system keychain. Let me pause this for a second. Okay, let's run this. Requires my password because I'm running a sudo, and then it requires additional password for the items that I'm importing. So I import a certificate and the key. Okay, so we're gonna start up our servers, two servers, a TLS server and a mutual TLS server. So docker compose up. We have these TLS servers running. So now let's try to access them. So we have client signer -URL. Just copy -URL. So this is the TLS server. Let's see. Hold on. This happened because I already had a previous server running. So I'm gonna do Docker compose up. Let's see. Okay, now we got these servers running with the keys that we just generated. So let's do. Okay, TLS hello world. We hit our TLS server, which we see down here, and then we're gonna do mTLS, and this is the message mTLS hello world, and this is just the messages that we printed in our code. So finally, we are able to use a mutual TLS server without having to point to files, to our certificate file and to our private key file. All right, in the next video, we're going to look at how to do this in Windows.